So now that we've gone through an update from related to different themes from the working groups and our new theme that we're putting together, I'm also going to highlight what we're doing, where Assess plays at COFES 2017. So in addition to this pre-COFES presentation, we're also going to have an Assess Initiative Technology Suite, which has 2 sessions tomorrow, one from 10 to 11 and one from 2:15 to 3:15. That's in Suite 5003, and I'll be talking about that tomorrow morning at lunch at the sessions. And we'll also be doing a roundtable on Saturday from 2 to 3:45 about facilitating the simulation revolution, and the roundtable is going to be a very open discussion. We're not going to be presenting. We're going to throw out some seed thoughts, and we're going to have an open discussion about the role of simulation in your activity and where you want it to go, how it should grow, and we're going to start opening up this collaboration and input. So now we're going to open it up for questions. I'm going to remind you that the Assess 2017 Congress is November 1st to 3rd in Potomac, Maryland. But now I'm going to open it up for discussions, and we can continue discussions at the COFES reception. At this point in time, we'll open up questions for anybody who has questions for any of the speakers or for me. Any questions? Comments? Can you stand up, please, Vince?
Yeah, hi, Joe. You're totally right on about the IP issue with any of the national labs. You hit the nail on the head. NIST, a couple of years ago, recognized the problem, and they made the application, like a 2-page application, and removed the IP requirements for startup companies to be able to work and roll out of the universities. But like in a place like Cornell, which has government-funded labs for like nanomaterials, a characterization lab, no chemical company could ever use the characterization lab to look at nanomaterials, carbon nanotubes, because of the IP. So they couldn't ever get Cornell or MIT or any of the chemical companies to be able to put aside the IP. So that was a major roadblock in the chemical industry. And so most of these labs are virtually unused by private sector because of that problem.
Well, I think you've highlighted a case where the research was done and people can't take access to it. There's another case where the research doesn't happen even though the teams are put together because the large university that has the research team says that they have to own the IP, and the commercial company funding it says, but they say they want full funding, and the commercial lawyers say if we're doing full funding, we own the IP, and it ends up being lawyers yelling at each other and nothing happens. Any other comments, any other questions? Please stand up and wait for a microphone.
Do you have a customer that has implemented this methodology to success? If the benefits are so self-evident, there must be a customer out there who is taking advantage of this.
Which methodology?
The Access methodology for simulation.
Okay, there are customers who are thought leaders who've actually made us see some of these insights. The aerospace and automotive companies, we can complain a lot about them, but they've been pioneers in the usage of simulation for a long time, and they've leveraged it successfully to turning it into a business advantage. They still have room to grow, but they've successfully made it a business requirement. It's quietly. They used things like optimizing testing, reducing testing costs. They used metrics that they could get a hold of in order to do that, but they're moving in that direction. There are pioneering companies like Procter & Gamble, which has managed to establish itself as a clear leader in consumer products, and the amount of simulation they do would amaze you.
Shouldn't they be upfront in part of your Congress to tell the rest of the world?
They are. They are active participants, and they are part of the.
But getting success stories.
Yeah, yes. And we're working hard on trying to get those success stories. And the challenge is, other than the high level, we'd use simulation, we did great success stories. Getting any meat, they struggle to share that.
Joe, great job. One thing I didn't see, but you probably have already done this. Are you familiar with the National Center of Manufacturing Science?
Yes,
Okay. And you all have approached them?
not yet. They're on the list.
Right. I suggest strongly, because in 13 we engaged them and talked to them. And there's a very, very strong effort where they have identified that group you call the small business. They call them the missing middle.
We also call it the missing middle.
But you got to coin something else.
Yeah.
I just strongly suggest that, because there's a huge effort in Michigan to be able to engage them to the point where they have identified small companies or small middle-sized companies and actually offered like a scholarship to offset some of the initial cost of the software, and identified those experts that they could put in front of these small companies. But you've already engaged them, so.
Now,
good.
what I would say, Ferris, is if you have some contacts at NCMS that we should be making contact with,
Yeah.
please share those with me, and I'll be glad to do that.
Absolutely.
Any other comments, questions? You know, the beer's not flowing yet. You got to wait a little while. It's 5 o'clock somewhere, and it's almost 5 o'clock here. Yes, we got another comment. Wait for the microphone, please, so everyone can hear you.
It's hard for me to believe that a COO or a CEO will make an investment without his engineering manager or the engineering team telling him he's going to make a ROI, he's going to get a return on investment. So don't you need the advocate at the bottom of the engineering willing to tell his managers, his high-level managers, that there's a success here?
Absolutely. The challenge isn't getting them to be willing to say there's a success or a win. The challenge is getting them to explain it in business terms and not the technology that they're enamored with.
So a lot of the engineers are certainly presenting good ROIs. It's the difficulty of getting the managers to listen. And frankly, a lot of the managers are sitting on ROIs, and they can pull out from their drawer from the last 5 years that said, let me tell you, that R, I didn't see quite as high as the presentation gave me 3 years ago, 4 years ago, 5 years ago. So there's a lot of skepticism about the ROI. And that's what we have to get past. It's how do we get management to listen to a valid concern from engineering for what they need to do to properly deliver these products to market.
So you're ending the business. You're ending the business value at the engineering level, so that they can present to the CEO.
We're aiming to understand what are the barriers. Okay? What are the barriers between what is it that the engineers are seeing, what are the managers seeing, what are the executives seeing? How do we actually get past this to get the right tools in the right people's hands? And that's what we need to understand more. Okay? In some cases, the people don't even have the tools because they're being held by one group and they only want to hold on to that particular set of tools themselves. Right? And so you have fiefdoms. So it's about the understanding, and that's what the assessment is trying to do.
So we have to communicate at multiple levels. It is communicating to the engineers, to the technicians about how to communicate, not how to do a better job. It's how to communicate how good a job they're doing, and it's also and how it can impact things. And it's also communicating the importance of simulation to the executives, so that when their technical people come up and present something, they at least know it's an important strategic concept. They don't have to be sold on that idea. So Assess is trying to bridge that gap of communication. And they see that that's one of the biggest business issues is bridging that gap. Because the CFO and the guy who does finite element analysis, about 3 minutes in, they stare at each other because they don't have a word they can exchange. Yes, Joe. Hold on, let's wait for a microphone.
In my role, I go out and visit customers all the time. And what C-level people are telling us is that they measure the performance based on either budget or timeline or both. So that's where they're making decisions. And
That's correct, and it's teaching, how do we explain that the understanding of better decisions reduces timeline, reduces budget, and reduces risk, because that's the other thing they speak about.
correct.
But the challenge with reducing risk, and this is something that Chris brought up earlier, if we negate the risk, if we can use this to make sure a car doesn't have any recalls, how do you quantify the value of that?
Right, and on that topic of, wrote it down here, I think it was Chris had brought this up, that success is not rewarded. My thought on that is, in the scientific community, they're publishing papers that have a significant result, and people aren't publishing papers that don't have a significant result. So it's sort of like the opposite.
That's correct.
So how do we, and there's a move towards publishing papers that don't have any significant results. So maybe, something to think about.
And one thing to carry on with that is we also have to acknowledge, and I've been in the structural analysis and CFD analysis, I've been in this space for about 40 years, and I can honestly tell you that 90% of the people in the space who do these complex simulations, they aren't the best communicators. And I'm being very politically correct. Or the joke would be, the extroverted ones at a party because they're looking at the other people's shoes. Okay, Jack?
Well, I made some other notes that I wanted to comment on.
Okay.
I agree that hardware is not as much of a bottleneck as it was before, but I like to think about how hardware could be taken to the next level. And the thinking that I had was, if you think of Watson that was competing against humans in Jeopardy, and the language, like just asking the question, the language of spaces in between, Watson could solve, world problems, right? So just the idea that hardware could do all these different things in the spaces that we're trying to figure out some problems is just an interesting thing. So if you take a look at the idea of the biggest problems of CFD that I see and that I deal with is getting neutral geometry file formats and then taking that and meshing it, and why shouldn't that be something that the person doesn't have to deal with? It's just transparent.
You took one of the major buzz phrases, transparent or invisible. Let's make the simulation just happen. We don't need an expert to set up every step. Today we do. The goal is that we don't.
And then lastly, I was listening to some things about how open source can help out, and I was thinking of how some of these problems that we're addressing is open source can solve a lot of those, because you're not solving, everyone's not solving the same wheel problem, and if there was a way to have an organization that could deal with managing the data, and then whether it be commercial or government or facilities, that they can take that data and just plug it in and use it. So sharing a data,
We'll have a
collaborating.
separate discussion about the advantages and disadvantages of open source offline. I've got Jack waiting, and then I'll come to you later, next, Mark, okay?
Could you clarify a bit?
Please stand up.
You stressed engineering simulation, but do you need to confine engineering a little bit? Because, for example, at the Salk Institute in La Jolla, there's an engineering group, engineering DNA sequences. And there's also a group now that's engineering legal documents so that they don't interfere with one another. So
It's a point well taken. However, their definition is already too long. So we'd have 20 pages to really isolate it perfect, but it is a point well taken, Jack. But what we're really trying to do is get to the group that's related to doing engineered products and engineering processes as we understand them in the electrical, mechanical world. And it's about then trying to say those things have a common set of characteristics because they have a common set of goals. So therefore, we can have a common set of issues and approaches that work. We excluded some of the other areas. We exclude a big portion of systems engineering because it doesn't have the same common goals. And it's absolutely necessary and vital, but it's not common. So therefore, we got too many objectives and we can't do anything meaningful. Okay, I think Mark Halpern, you had?
Yeah. I've been in this space about as long as you have.
Yes, I think we started about the same time.
Yeah. What I wonder about is essentially the scope. You know, you made a comment about producing a car without recalls. I don't want to get into a discussion about the features and functions that need to be in CAE, but the reality is that you can't identify defects unless your models have a level of fidelity to detect them in the first place. So let me give you an example. I went through the NHTSA database of all of the recalls, the reasons for the recalls. Some of them, in a lot of the CAE we'd never capture. For example, one was a seat, a baby seat in the back. One of the recalls was that during a crash, the seat would lunge forward, the belts would tighten, and then there was a little flange of metal that could slice the belts. I think we need other technologies like FMEA, or something complementing this, that if we're going to try to achieve the goals. I would also iterate that there is relatively little work on the economics of this. But I'll also say, being at Gartner, I get to see a ton of contracts from MSC, ANSYS, Dassault, you name it. I'll tell you, these companies are spending a ton of money on FEA already.
No, and when we're talking about engineering simulation, we're talking about a lot more than FEA. When we talk about the scope of assess, it includes the systems engineering, but it also includes FMEA. It includes all the sorts of simulations necessary to predict behavior, not just FEA and CFD. Everything that's necessary to simulate the behavior, the failure, the usage. It's about doing a complete engineering, it's covering the whole spectrum of engineering simulation. So that's the first thing that assess, I got to clarify, is assess isn't about FEA and CFD. It's about all of this and actually bring it all together. The other realization is, Mark, I think I'm one of those who believes we have about 90 to 95% of the technology we need, but it's really not in a way that people can leverage it and use it. And we need to improve that. So it's possible to go to the high fidelity models. The other thing is, with the example you've given, you know that the automotive manufacturer who's had that problem and had that recall, they're putting together models to predict so it doesn't happen again. They have to. They can't afford another one. Where do you think a lot of the crash stuff came from? Where do you think a lot of the analysis, this is now standard work in automotive and aerospace, came from? Because there were recalls and failures which were too expensive and could never be allowed to be repeated again.
No, I know that's, the idea is, well, never mind. This could turn into a
We'll
much
have
longer.
you and I always have good conversations on this, Mark.
But
I'm going to pass on to one more person's got a question.
I was just concerned about the scope.
Okay. Well,
Okay, I had a question related to the business, the economics of simulation. And if you look at every manufacturer's website, they talk about we're going to have the most innovative products in this field, right? We're going to have the best products. Nobody's website says we're going to make a ton of crap, right?
Right.
We're going to make the best products. So the question is, has anybody done the ROI on making the most innovative product? What's the ROI of getting a more innovative product to market earlier? You know, you gain some price authority by getting to the market earlier, but if somebody could quantify that, then that may be a way to lead into the ROI of FEA or analysis.
I think that makes a very, you're right. I don't know of any research offhand that has that, but there's probably, Mark's company, Gartner, would probably be a good company that might have some information on that. And so that the research like that could actually be dovetailed into this simulation, then enables this much more innovation. Therefore, we can actually quantify it in some way. But I think there are companies, I think like SimData and definitely Gartner, which would be more qualified to do that sort of research or sort of report. So that, check with Mark, see if Gartner's done something like that.
I had an old one. Now I am. See, he knows back there. See? He just had to see it. So, but if you look at innovative company, you look at Apple, right? And you can see market capitalization that says that they are being rewarded for innovative products that do work.
Tesla, SpaceX.
Tesla worth more than Ford now, right? As of last week. Market cap higher than Ford.
Let's go to Paul in the back.
Hey, thanks for taking a back row question.
Make it easy.
Okay, just talking a bit about your comment earlier about focusing on different markets. Do you see the AEC space as a target of what you guys are doing here?
Absolutely. Actually, the assess market is about all industries, all use of engineering simulation. So it's engineering simulation for geophysical, which I know is key for you, AEC, shipbuilding, anywhere where engineering decisions are being made and supported by simulation. So it's, the intent in assess is to be all-inclusive.
A lot of the details sound more from a manufacturing basis.
Yeah, we
at
have
least where you are so far.
Where we are so far is we have a very strong manufacturing bias because most of the people come from that space. We would love your input on the geophysical.
Okay, thanks, Joe.
Keith?
Joe, if I could just make a comment that, I mean, there are examples around. For example, last week, GM announced their new small SUV that is 400 pounds lighter than the one it replaces. And it's slightly bigger on the inside. And any auto manufacturer could put a price on that. Yeah. And GM has figured it out. The Cadillac ATX is nearly 400 pounds lighter than the BMW 3 Series.
Oh, we have another question right here. Caroline's has him, Bonnie.
Is this on? All right. I like your focus on how do you sell this to CEOs. I'm curious if you're missing a segment, though. Everybody that comes here is probably pretty progressive, but you start talking small and medium businesses, you got a lot of resistance even out of engineering. You're going to make the software easier to use, so you don't have to have as much technical skill because it's a constrained resource. It's not engineer in a box. You're not going to have engineers promoting that. I think that's a strong barrier to adoption, especially in the construction industry. It's a highly social activity, complex systems interacting. You got teams of people who've never worked together before, and probably won't work together again. I could build two of the same building and for the same owner, and they have different objectives out of it. You see, I see a lot of people that, hey, I don't want that software. I don't trust it. I don't want a non-skilled guy. I want my guy doing it by hand. There's a pride in engineering. I'm curious if that's a focus of what you guys are doing too.
That is a focus, and there was one of the points on Chris's slide, which is about addressing the small to medium-sized businesses, and it's for two major reasons. One is it's where the growth potential really is, because there's where there's a potential of expanding the use significantly. The second is that it has a totally different set of requirements and dynamics to get penetration. And it's about cost, it's about very simply, but it's also about, you know what? That CEO may be the brother-in-law of the engineer. And it may be, it's not this communication of the CFO doesn't know how to talk to the other guy. It's a matter of, I'm used to doing it this way, why would I invest anything in it? And it has to be much easier, it has to facilitate, it has to be clearly a slam dunk that doing this is better than not doing it. And we need to work a lot easier about that, because the pricing, the structure of everything is really geared for large simulation teams, and we need to change. That's part of what we need to do. And you'll notice that there wasn't a lot of bullets on that slide because of the fact that we're really having a lot of discussions to wrap our head around that issue, because it really is a whole new set of issues, including the cultural issue you said of it, I don't want to change. So we recognize that as a key area, and we're in discussions to understand how to go forward with it. And love your input. We got one more question from Fuad.
I'm not sure if it's a question or comment. I always wonder what does mean ROI for simulation, to compare to what? If I can understand that we can have some use cases where we can show problems that it was solved, but if the standard process, what does it mean? We can set a parallel process without simulation to compare both, what's the benefit and so on. Well, this is just comment. Second comment is, while moving to digital transformation now, simulation will be just part of one full chain. So how we can segment this and to measure the ROI for each one, it will be impossible.
This movement to the digital transformation, the digital twin, the IoT, these are part of the reasons why not only do we want to do more simulation for better, but you start thinking about digital twins, especially for every part that's manufactured. That's where my 10,000 number, my 10,000X comes from, because now all of a sudden this is going to explode the need for doing these simulations. Okay, I think we're going to go ahead and wrap up the session. Thank you very much.